Hello guys, very good morning. Welcome back and let's start. So in the last session, we discussed about the concepts related to Docker. So what is meant by a container and how we can create the containers and what are the prerequisites and depending on the namespace and control groups, we can create the containers and how they will be working, how to install the Docker on the concern server. So these are the concepts that we have seen in the last session. Right? And in this session, what we are going to do here is we will be understanding the concept. We will be understanding the architecture of Docker, how we can create the Docker, how Docker will pull the, or else how Docker will work with the containers. So all these concepts we are going to discuss. So this is the last demo for you. And in the next demo, tomorrow onwards, there won't be any free sessions. Okay. So the demos are closed today by today itself. So please be cautious on that. Okay, now let's get started with the concept. Again, I am telling you the session will start at 8:30. Okay. Few days. I don't know. I won't say that, but at any given point of time, we are going to start the session by 8:30 or 8:31. Please try to attend by 8:30. Okay. Right. So now, so already Docker is running on our server. Okay. So now let us understand the Docker architecture. Even I just created the Docker desktop also. Docker desktop is also installed on our server, on our Windows machine. So if you see here, here you can see this is the Docker desktop which we are using. So the same commands I said, so in the Docker, we will be using the same commands. So how we are going to work with the commands in both the Ubuntu and Windows environment, let us see that. So when we go with the, let me go with PowerShell. Okay. So here you can see Docker PS. So I am working with the Windows environment. So when I start the Docker desktop, here you can see whatever the containers that are there, that is going to be displayed. So Docker PS or else Docker PS-A, the same commands. So in Linux also, we are going to give the same commands. Docker PS, Docker PS-A, okay, Docker PS-A, and then we will see Docker images. So whatever the Docker images, do we have any Docker images? If you see, so we have a few images in the Windows environment. Okay. So depending on the requirement, we are going to check out whether the Docker images are available or not. So that is how we will be working with. Now, for example, if you want to create a container, okay, if you want to create a container, what is the command we will be using to create a container? So as I already said you, so we will be using docker run -itd hyphen name of the container, docker run -itd name of the container is web container, or else I can go with let me go with web container 1, and with the image I can go with nginx. Okay, so if I want to provide the version, you can provide the tag. Okay, you have to provide the tag. Otherwise, if you simply give nginx, then automatically what Docker is going to do, Docker is going to add a tag called as latest, and after adding the tag called as latest, then it is going to download that particular image. So now what is going to happen in general? So what is this Docker architecture and how we are going to work with that? So whenever we are working with the Docker, so there will be three things which are most important. The first one is Docker client. The first one is Docker client. So how we are going to communicate with the Docker application, or else I will call it as Docker CLI, the command line interface or the client. So when we want to provide the commands, we can provide Docker run. So we will give docker run or docker if I want to build an image, docker build. Or else if I want to stop the container, docker stop. If I want to create a network, docker network. Okay, if I want to create a volume, docker volume. So every time, whenever I want to do something with Docker, so if you see in the beginning, I am going to give a word called as Docker. In the command line, I am going to give a word called as Docker. So it will trigger that. Okay, so the user want to communicate with the Docker application and he has to do something in the Docker application. So that is what Docker CLI and Doc, or I can call it as Docker client. So when I give the command, so in our system, in our computer or else in our server, there will be a Docker daemon. So if you see, this is the Docker environment. Inside that, we will be having a Docker daemon. This command will be, whatever the commands that we are running, the commands will be reaching out to this Docker daemon or else Docker service. Now, if you see here, the Docker desktop is running so that I am able to give the command docker ps. When I give the docker ps command, it is showing that there are no containers running. So when I give the command docker ps, what is going to happen? It is going to hit to the docker daemon, and the docker daemon will communicate with the containers. Are there are any containers? If there are no containers, it is going to show you that no containers are in the running state, or else there are no containers in the Docker environment. Okay. So, but what I will do here is, I will stop the, I am going to shut down this entire Docker desktop, close it, and from here, it will be running in the background. I am going to quit the Docker desktop. When I quit the Docker desktop, so you have to click quit the Docker desktop. Or else, if you want to do it in the Ubuntu machine, what you have to do, systemctl stop docker.service and as well as systemctl stop docker.socket. Both the things I will stop it. Now, if you see docker ps, so I'm going to get an error. What is the error? Docker daemon cannot connect to the Docker daemon. So the request, whatever the command that you have given, the Docker daemon is unable to listen to that. Okay. So in the same manner here also, in the Windows also, when you give docker ps, I'm going to get the same output. So during the connect, error during the connect, so the system cannot find the file specified. It is unable to connect to the Docker as the Docker is not running in the background. So the system is unable to connect to the Docker. So again, which means that the Docker daemon is very important. Without Docker daemon, we cannot configure the, the communication will not happen between the client and to the Docker application. So definitely we need to have the Docker daemon running. So let me start it again. Docker start and docker start docker.service. Okay, good. So now if you see, again, once we have started the Docker daemon, now we are able to get the resources back. So in the same manner, in Windows environment also, when I start the Docker desktop, we are able to see that the application is running. Okay, application will be running and we can work with the containers. So this is good. So now what we are going to do next. So once this Docker architecture is there, now if you want to create the container, what are the most important things to create the container? What we need to create the container? Which resource we need to have to create the container? Tell me, guys.
For the application,
Not the application. Inside the container, you can install the application. But first of all, if you want to create the container, what is required?
we need to a Docker file we required.
Docker images. Why we need to have the Docker file? So we need to have the Docker images. Without Docker images, we cannot create the container. Okay. So we need to have the Docker images. So in general, these images are stored in the Docker registries. There will be a Docker registry in the local server. So that is internal Docker registry. global Docker registry, global Docker registry. There is another type of registry, that is global Docker registry, and private Docker registry, private Docker registry, or else private registry. So what is this internal Docker registry? Internal Docker registry, in the sense, for every server, there will be an internal registry is there. Registry means it's a storage where it can store the images. So if you see here, right now, when I give Docker images, it is going to show me some images. Okay, so this is the images that are present in my local machine. If you see in the images, here you can see the images are available now. So this is in the internal storage. If I go to the Ubuntu server, here you can see Docker images. In the local storage, we don't, or else local machine, we don't have that images configured, or else the images are not available over here. So this is the local registry. Now, what is meant by global registry? There is another registry that is available, that is called as global Docker registry, nothing but your Docker hub. So if the images are not available inside my internal registry, inside the internal registry of my server, then what Docker is going to do here is, so for Docker, there will be a global registry called as Docker Hub. It will go to the Docker Hub and pull out the images from the Docker Hub. So if you see here, there will be hub.docker.com. I will go to this particular URL. By default, Docker knows about the Docker Hub. So now what I can do, I will log in into my Docker Hub account. Okay, this is my account. Okay, so there will be global images are available. For example, I want the Nginx image. So if you want to get the global images, you don't need to have any account also. There is no necessity of account. Simply let me sign out of this account. So let me show you from the, without signing into the account also, you can get it out. For example, I want the Ubuntu image. If I want the Ubuntu image, here you can see Docker official images are available in the global registry. When you click on this, Ubuntu is a repository. See in the GitHub also, if you see, if you take the GitHub, I'm just giving an example, guys. So that doesn't mean that this is something different. So if you are creating a project, so where you will save the project, you will update the project in the GitHub. So when you make the changes, so whatever the project that is stored in the GitHub, that is the version 1. If you make the changes in version 1, it can come up to version 2. When it come to version 2, you will upload the project into the GitHub. So there will be version 1 and as well as version 2. But the repository is same, no? For example, I am creating a login request or else login application for an user account. So whenever I am creating the login application for an user account, so I will create a repository called as login repository. Inside the login repository, what I will do, I will create the application. When I create the application, that is version 1. Initial stages, it is version 1. When I update the code and reapply the configuration, then it will be coming up to version 2. But the name is same only, no? In the same manner, here also what is happening? The Ubuntu is a repository. Inside that, we will be having the different versions of Ubuntu under the tags. So here you can see latest Ubuntu will be there, and Noble, latest, and 25.10, 24.04. Like that, different versions of Ubuntu is available. Depending on your requirement, you have to choose the Ubuntu which version. Okay, Ubuntu with which tag you want to create, that you have to select. In the same manner, if I want to create a web server, so I will go with Nginx application. Nginx. So if I go to the Nginx application, Nginx is a web application or web server. So in Nginx, we will be having, what was that? Yeah, in Nginx, we will be having, so this is the Nginx repository. Inside the repository, we will be having the multiple versions of Nginx. Whichever you want, you can pull it out and you can create a container. Now, this is a repository where all these repositories are stored. Now, Ubuntu is a repository. Inside Ubuntu repository, we are having the different versions. Nginx is a repository. Inside Nginx, we are having the different versions. So if you want the PostgreSQL, Postgres, okay, it's a database. PostgreSQL is a database. So now when you see the PostgreSQL, under PostgreSQL, we will be having different types of versions. Postgres 15, Postgres 17, Postgres 14, like that. Depending on your requirement, you have to choose the version. Okay, so Postgres is a repository. Inside that, we will be having the different version. In the same manner, Ubuntu is a repository in which we will be having the different versions. So all this repository collaboratively, they will be inside a registry. So this is the Docker Hub registry. So there will be registry inside that. There will be repositories. Inside the repositories, you will have each version of that particular repository, that image repository. So now if you see here, in the images also, there you go. It is showing the repository and it is the tag. For example, kindest/node. So there is an application called as kind in Kubernetes. But anyways, if there is a time, I will tell you about the kind in the Kubernetes also. But the point is, so this is a repository. From this repository, it is downloading this particular version of image. Okay, in the same manner, when we go for the Docker images, when we are downloading the Docker images, depending on our requirement, we are going to download the Docker images. Not only Postgres, not only Nginx, not only what I can say, Ubuntu, you will be having every image related repositories are available. For example, I want Tomcat. So Tomcat is also available. Okay, Tomcat is another web application. For example, I want Java. So Java related images are available. For example, I want Python. Python related images are also available. Depending on your requirement, what you can do here is you can select the image. So if I select the Java image, by default, there will be operating system environment where Java is pre-installed. You don't need to install the Java after creating the server. Okay, if you take the Ubuntu mission, Ubuntu will have only the OS environment. Inside that, we don't have the Java. But when you take the OpenJDK image, inside the OpenJDK image, there will be Java installed by default. So I will show you that. But as of now, what I will do here is I'm going to create a container. Docker
So
run. Mhm.
I'm a bit confused about registry and repository. I mean, what is the difference between registry and repository?
Okay. You have a computer. Inside the computer, you are having a project folder. Inside the project folder, you are having different versions. Now, computer is a registry, folder is a repository, and project versions are your tags. Now you got the difference.
Okay. And we can also upload our repository inside of this registry, right?
Yeah, you can. If you create your own custom image, you can upload your custom image into the registry, and from there you can pull out the image into the another server also. That can be done.
Okay.
Now, yeah. So whenever we are trying to create a container, so I want to create a container, Docker run -itd -name, test container one, and with the image Ubuntu, you can take Ubuntu 22.04. Let me take like this. This is the version which I am going to take. So Ubuntu is a repository. So Ubuntu is a repository and 22.04 is the version. So now what it is going to tell you here is inside your local registry, inside the local registry, inside your internal server or else inside the Docker server, there are no images. As there are no images, but you are trying to create a container with the image Ubuntu 22.04. Now what Docker will do here is Docker will communicate with the Docker hub. It will connect to the Docker hub, and inside the Docker hub, it will check for the image. Okay, it is going to check for the image Ubuntu 22.04. So if the image is available, then it is going to pull out the image from the Docker hub. And what it is going to do here is it will store in the local or else internal registry. So this Ubuntu repository and the version will be pulled and it is going to store in your local registry. And from the local registry, it is going to create the container. Whatever the image that is available here, from the image, it is going to create the container. So let's see. See there, unable to find the image Ubuntu 22.04 locally, pulling from the library Ubuntu. Library Ubuntu in the sense it will check in the Docker hub and it will check about the Ubuntu library. In the Ubuntu library, it is going to check, and from here it is going to pull the version, that is 2204. Okay, so this image has been pulled out from your Docker Hub and stored in the local registry. There you go. So the Ubuntu image is stored in the local registry. With the image, we created Docker has created the container. So here you can see test container 1 is created, and this is Ubuntu 2204. So this is how we can create the container, and this is how the Docker architecture will be looking like. So whenever we want to create, or else whenever we want to do anything with the Docker, first Docker will communicate with the Docker daemon. So whenever the user gives the command, how user will give the command to the Docker client? There will be a Docker client. The user will communicate with the Docker client and provides the command. And then what is going to happen? This command, whatever the command that we have given, that command will be given to the Docker daemon, and Docker daemon will understand the command and it is going to execute. What is the user requirement? User want to check out the Docker containers. So that is why he has given the command Docker PS. If the user want to create a container, the user is trying to create the container. So that is why he has given the Docker run. So it will check for the images in the local mission or else in the local registry. If the local registry, if we have the images in the local registry, then it is going to pull out the images from the, then it is going to use that local registry images and it will create the container. If the images are not available locally, which means inside the server, then Docker daemon will contact the Docker Hub, and from the Docker Hub, it is going to pull out the Docker images and it will create inside it will store inside the local registry. From there, it is going to create the container. So this is the process of Docker. This is how the Docker will work. So that is the Docker architecture. So there is one more registry that is available. That is the private registry. If you see here, Docker Hub is a public registry where everyone can access, the images, whatever the images that are available in the public registry. They are not, I won't say they are not safer, but the problem is, for example, if you want to create your custom application for your company, so your company is creating an application or else they have a joint venture and you want to create an application or else application related container. For that, what you are going to do, so you will generate an image, custom image for your application. So you cannot put that custom image or else the application in the, the application inside the image in the public registry or else public platform. So if I put that in the public platform, everyone will know about the application. So I don't want that to be happen, no. So we need to maintain some privacy. Then if that public registry is not there, then what we have to do? Either we can store it in local server, or else if that image should be accessed by the multiple servers. See, in the Docker, we will have the Docker server. For example, that is in the development environment. If there is another server in the production environment, they want to use the same image. If I want to use the same image in the another environment, then I have to SCP that. We can do the secure copy from one server to the another server. Or else what I can do here is I will create a private registry. I can create my own company's private registry with the help of certain tools called as Arbor, or else there is another tool called as Nexus, where we can create the private registry. So I will show you how you can create the private registry to save the images. But anyways, if I am developing my own application and as well as I am integrating that application with the Docker and I want to run with the container, I need to create the images. So without creating the images, I cannot run the application inside the container. So to create, after creating the custom image as well as after creating my own private application images, I cannot provide that on the public platform in the Docker Hub. So what I will do here is I will save that image in the in the private registry. So when I save that in the private registry, to log in into the private registry, definitely the user need to have the credentials. Without credentials, the private registry won't allow the user to enter. So you will understand this, but as of now, there will be another type of registry called as private registry where you can create your custom image. For example, this is the student app image. Okay, so this image is a private image which I am creating. and I am storing in the local harbor registry. Whenever I want, I can pull out it from the local harbor registry. So this is also one of the registries that are available. If you see here, we are having internal Docker registry, that is nothing but your local registry that is created inside the server. And there will be global Docker registry, nothing but Docker hub. And there will be a private registry, nothing but the registry which is created for your own company, own organization, that is with the help of certain tools like Harbor or else Nexus. Okay, like that you will be having different types of tools. I just told you only two tools. There are so many tools are available. If you want, you can create in the AWS ECR also. Elastic Container Registry is there. Azure Container Registry is there. ACR. For Google platform also, there is a separate container registry is available. So those are all comes under the private registries. Any which ways. So this is how the images are stored and pulled and created, and they will be created, creating the containers inside the Docker environment. So this is the entire Docker architecture. Now, do you understand what is a Docker architecture? Any questions?
Yeah, Chetan, uh, can we not create private registry in Docker Hub itself?
You can create, but it is costly. You have to pay for that.
Okay.
So if you see, I can store up to, if I log in into my account, okay. If I log in into my account, this is the repositories. No, in the repositories, what I can do here is, I can here you can see the personal hardening images, in the sense of checking the security. If I go back here, I can create a registry. Here you can see. Where is it? Create a repository. My private repository, only visible to me. So how many private repositories I can create using 0 out of 1? Only one private repository I can create in the free tier. But if
Okay.
I make it as a subscription model, then
Mhm.
there you go.
Okay, $9
So
have to pay.
$9
Yeah, I got it.
per month, or else you can go with the annual cycle. So you have to pay $108 to create a private registry in your Docker Docker Hub. Okay, so I won't say in the Docker Hub you cannot create the private registry, but most of the people will use the Docker Hub as a global registry. They will create
Okay.
their own private registries. Okay, right. So this is about your Docker architecture, and if you see, I mean, this is what I have given in the paint, but if you see in the image format, the same will be there. But anyways, I just want to show you that also.
I have a question, sir.
Yes.
So you were going over the other day about how we had, kind of the layers where we have our hardware, and then we have our OS, and then we have our Docker. And this architecture that you're showing us sits on that Docker layer, right?
Yeah, this will be entirely on the Docker layer.
Okay. All right, cool. Thanks.
So this is the Docker architecture, which we have discussed: client, Docker host, and the registry. So whenever the Docker build, if you want to build an image, you can communicate with the Docker demo, and the images will be built. Through the images, you can create the container. Build in the sense creating your own custom image. Docker pull means you can pull this image from the Docker hub, from the global Docker hub, and you can save it in the local registry. From there, you can create the container. Docker run container means creating the container with the help of images. So either the way you can do that. So this is the concept and this is the architecture. And then we will be discussing about the Docker, or else I will call it as container lifecycle. How containers will work, what is the use case of containers. So there will be container life cycle. Okay, container life cycle in the sense how containers can be created, how containers will be working, and how we can make the containers stop, pause, like that. So the first stage in the container life cycle is that the containers will be created first. So Once the containers are created, we are going to start the container. Create, and then we will start the container. Once we have started the container, then the container will come into the running state. But we are bypassing these two stages, that is create and starting. We are bypassing these two stages, and directly we are going into a stage called as Docker run. When we give the command Docker run, it will create and start the container and make the container come into the running state. So this is the Docker run command. Okay. So whenever we are creating the container, or whenever we are trying to start the container, we are going to give the command Docker run. But what we can do here is we can Docker create -it -name. If you don't provide the name, automatically Docker will create a name. Okay. Any another custom name. Okay. So if you want to provide a name, you can provide it. Test container 2. And with the help of Ubuntu image, I want to create it. This time it won't go to the Docker Hub, as the Ubuntu 22.04 is available in the local machine. It will just create the container. So if you can see here, Docker PS, test container 2 is not showing. It is showing only test container 1. Why? Because it is created. Docker PS is a command which will be displaying only the running commands, running containers. So now if you see, whenever we give PS in the Linux environment, what is meant by PS in the Linux environment? What it is going to display? PS will display the running processes in your Linux environment. In the same manner, here also Docker PS. Docker PS in the sense show the running containers. So it is going to display only the running container if you give the command Docker PS. Now I will give Docker PS -a. When I give this command, no, so here you can see it is showing all the containers which are created, stopped, and running. So here you can see test container 1 is running. Test container 2 is in the status called as created. It is in the created state only. It is not yet started. Now what I will do, Docker start test container 2. When I try to start it, now here you can see Docker PS test container 2 is started. 1 minute back it is created, just 2 seconds back it is started. So now it is into the running position. So there are two steps that we are skipping by giving the command Docker run. So when we give the command Docker run, it will create the Docker will create the container and start the container and take the container into the running state. But what you can do here is you can go for the create and start. So once you have started the container is in the running position. Okay. Now, if you want to enter into the container, so if you want to enter into the container, you can give a command called as docker execute -it test container and bash. So as it is an Ubuntu environment, you have to give the bash. Bash is an own again shell, which will display a shell in front of you. But if you are using Alpine Linux, then you have to give sh. Depending on the image that you are using, you have to give either shell or bash. Okay, so I'm logging into the container. Test container 1 no. So test container 1 and bash. Now, if you see previously, I am in the server. So that's why you can see here 172.21.200. So this is the server IP or else server name. But now if you see here, we are inside the container. So here you can see the container ID, CF8DC. So what is that? That is the container ID. For test container 1, the container ID is this. Okay. So now we are inside the container. Now what I will do here is, let me apt update -y, and inside the container I am running certain commands. Apt install -y stress. Let it come. I'll take a duplicate session over here. Sudo su -docker execute -it test container 1 and bash again, or else let me not do this. Whether the stress is installed? Yes. So what is meant by stress? Stress is an utility or else stress is an application which will apply the artificial load on your container. Okay, so now if you see, when I give stress, what will happen? I want to run the stress for 10 minutes. Now, if you can see here, when I give the command Docker stats, I want to know the current stats of Docker, how many containers. So if you see, the container one is consuming more than 100%, 200% of the 200% means I am having two core processor. So for each core, 100% and 100%. Now the container one is consuming all the CPU. So there will be certain applications. So for example, there is a data analysis application, or else there is what I can say, data monitoring, or else data simplification applications like that. You will be having some applications are available. So these applications will be consuming the more amount of CPU. So when they are consuming the more amount of CPU, the CPU will not be available for the another containers to start. So for example, if I have to start a Java application, in the initial stages, the Java application or else the Python application requires more amount of CPU to start the application. Once the application is started, they will come back to the normal state. Okay. But now what is my requirement? My requirement is that I am having a data analysis application which is running and it is consuming the huge amount of CPU. That should be running. Why? Because it is a 24/7 process. It has to analyze the each and every point of the data that is coming. For example, there is an e-commerce website is there. In the e-commerce website, so I want to take the analysis at any given point of time, how much amount of production is happening, how many mobiles are the people are purchasing, or else how much amount of money is transferring. So everything I need to check it out. So for that, I need to have a data analysis application which will be running to analyze the end-to-end data. So which will be consuming lots of CPU. But now what is my requirement? See, at any given point of time, it is not a very, very important application to run. We can pause it. Why? Because my most priority is to run the applications. So I will create another container. Whenever I am creating the other container, so this container one, just assume that container one is a data analysis application, which is consuming the huge CPU. Here it is consuming 200% of CPU, but understand, think like imagine that it is consuming huge amount of CPU. So, but a partial amount of CPU is required for the another container to start. So then what I have to do here is I cannot shut down this container. I don't want to shut down this test container. Why? Because it is mandatory for me to run the container, to run that application. But what I can do here is until the second container is started, I can pause the container so that the second container will start the application and it will start performing the operations. If it wants the CPU, it will grab the CPU also, no problem. So now the point is, I want to pause the test container and then I want to start the test container too, or else I want to start the application container. Is there any possibility that I can pause? Now, what is the functionality of a pause? Can anybody tell me what is the functionality of a pause? What it is going to do? Hmm. I will give you an example. For example, you are playing a game. Whenever you are playing a game, you completed a level 1. As you completed the level 1, now you are into the level 2. Okay, when you are into the level 2, the game will be saving it. So you are into the level 2, suddenly your family member called you and asked you to get something. Okay, it is a 10-minute task. It will be completed within 10 minutes. So now what you are going to do here? Are you going to stop the entire game and go to that particular shop and get the things, or else are you going to pause the game and go to the nearby shop and get the things back? What you are going to do here?
I will pause the game.
You will pause the game, obviously. What is meant by pausing? Pausing means it is not going to, which means when you resume it, when you resume the game, you will be starting from the level 2 only. But when you stop the game, when you completely stop the game, of course levels will be stored in the hard disk, any which ways it is going to start from the level 2. But my question is, you don't need to start from the beginning. Okay, if you close the entire application, if you shut down the computer and close the entire application, then again you need to start from the beginning. So the point what you need to understand here is, Whenever we are pausing the application will be stored inside the RAM. So whatever the RAM utilization is there, the RAM utilization is common, but the processing will not be happening. So that is the meaning of pause. So when you pause the application, it doesn't mean that the entire application will be removed from your computer. The application will be present inside the computer, but it is not going to be processed. Okay, simply if I have to say, you have a plan today. Okay, you have a plan today in the sense you want to go for a movie. Okay, so you stored in your, your brain has stored that at this particular time we have a movie plan, so we need to go. Now, whenever you are attending to this session, when you are attending to the session, that will be there. The thought will be there in your brain, but it is not going to poke you continuously. You have to go to the movie. Okay, at that time it will tell you that, which means that that is not completely deleted. It is there. Okay, it is in the pause state. Whenever this process is completed, process in the sense whenever your session is completed, then you can again rethink about that. So which means that the data is still in your brain, but your brain is not processing the first data. It is processing the class data. Right now, whatever the class is happening, it is processing that. Once the class is completed, then what is going to happen? Your brain will again trigger you that we need to go for a movie at this particular point of time, which means that still it is stored in your memory. Your memory is giving it to your brain, saying that you need to process this and tell to the human that he has to attend for a movie. So in the same manner, here also when we pause the container, the application inside the container will not be removed. It will be there. But what is going to happen? The process will come to 0. So to show you that, what I can do here is, this is the another life cycle. Docker pause test container 1. When I pause the test container 1, here you can see the CPU utilization has become 0, but there is the memory utilization, which means that it is still, the application is still running inside the memory. Okay. So if the test container 2 is started and the application is running and everything is happening good, then what I can do here is I can go for Docker unpause. If everything is fully, there won't be any problem. Everything has happened for test container 2 and it is running safely. So we can unpause the test container 1. So when we unpause it, again, it will go back to the processing state. So it will not go beyond, like as I have applied the stress, it is going beyond 100%. But in general, if some applications will be there, which is going to consume huge amount of CPU, I don't want that to be happen at the time of starting when another container. So other containers also require the CPU. For that reason, I'm going to pause one of the container so that the application will not be deleted, but processing will not happen. So I'm going to give this processor to the another container to start. Once the other container is started, I will I will unpause the previous container. So that is what pausing and unpausing state. So whenever the container is in the running state, we can pause the container, that is Docker pause. Whenever the container is, I want to get it back to the unpaused state, or else I want to get it back to the running state, what I can do, I can go with the Docker pause. And when I want to make the container to get back into the running state, Docker unpause. We can do the unpausing. So it will come back to the running state. If I want to shut down the container completely, so I don't want the container to be running, so I want to shut down the containers permanently, then what I can do here is I can go for stopping, Docker stop. So the application will be, the application will stop executing when the container is stopped. So here you can see, when I say stop, the container will be stopped. It will be coming into the stop state, Docker stop. And when you want to start the container back, you can go for Docker start. Okay. So if you want to shut down the complete container, now what you can do here is you can go with Docker stop test container 1. So when I say that, automatically. That's here you can see the test container will be removed from the stats. Why? Because it is stopped. Then what is the need of showing the stats? Okay. When the system is running, it has to check for the system CPU utilization and RAM. When the system is shut down, then what is the CPU and what is the RAM utilization? There won't be any CPU and there won't be any RAM utilization. No. Here also the same process. When I stop the container will be permanently stopped. Permanently stopped in the sense the application will be stopped and it is not going to run. So it is the Docker stop and start stage. If you want to start the container back, you can start the container where the application will be started from the beginning itself. Docker start test container 1. Again, the application will be started. We have to start the application back. So that is the start and stop state. And finally, we are having remove. When the container, if you don't want the application to be running, so you have the version 2, updated version of container is there. I don't want the earlier version of container. Then what you can do, you can stop the container and then only you have to remove the container. It is the best practice to stop the container and remove the container. Without stopping the container, please don't remove it. So we need to go for Docker RM. So Docker RM in the sense, after stopping the container, you can remove the container. You can remove the container when it is running state also, but you have to do it in the forceful manner. So you can remove the container forcefully, Docker RM-F. But this is not an recommended practice to stop to remove the container. So you have to stop the container. If you don't want the application to be running, stop it, then remove it. If you remove it forcefully, then what is going to happen if there is another requirement, then it will not be available. You can remove the container in the creating state also. When the container is created and you don't want the container to be started, then you can remove the container after creating also. Okay. So this is your Docker container lifecycle. So we can create the container, we can start the container so that the container will come to the running state. We can pause and unpause the container so that the CPU will utilization, the processing will be 0. And then we can start and stop the container. If you don't want any application to be running, you can remove the container if you don't want the container at all. If you are having another version of the application is available, you don't want the older version, then you can simply remove the container. So these are the container life cycles. Now you understand what is meant by a container life cycle. Any questions?
Docker path, we can log in. We can log in the Docker container whenever.
No, we cannot do that.
Okay.
See, understand this. If you, if what I can say, if you pause the container, the processing itself will coming to the 0. No, and the processor is not at all running. When you give the command also, whether the container will understand that. If you give a command, the container has to understand what you are trying to do. No, so here to understand that the processing should be happening. Here, what we are doing in the pause state, we are making that the container should be 0 with the processor. It should not run any processing. So then if you try to log in also, the container will not understand. No?
Correct. So in what cases we can use, because like Docker stop actually, yes, I know that we can use most cases. In Docker pause, what cases we can use?
I said, if yeah, there is an application,
resource management. Okay.
if you need to provide the processor for the multiple containers to safely start the application, then you have to pause the container which is consuming the huge amount of CPU. But I don't want that container to be stopped. See, I already said you, there is a data analysis or else there is a container which is working. For example, there is a queue services, is that Kafka queue services or else any containers like that, which will consume huge amount of processing whenever they are working. But I don't want to stop their work. I want the containers to be continuously running. But what is my requirement at present? See, if they are not that much, utmost important is not given for the containers, I can pause it for a while. See, if we are having a production application to be running, this containers, whatever the data analysis or else whatever the queue services are there, they can hold for at least 5 to 10 minutes. We can hold them and we can make the production applications to come up, and later we can unpause them so that the application will be keep on running only. Whatever the data that is given by the user, that will be collected and stored in the RAM. Processing will not happen. If the processing has to be done, we have to unpause it. Then when the processing is started again, then whatever the previous data that is given and whatever the new data that is given, that will be processed. Okay. Why? Because data will be stored in the RAM. No. So I did not say that RAM will not be given.
Yeah.
Okay.
Yeah.
RAM will be always, the application will be stored inside the RAM. When the request comes to the container, the request will be stored inside the RAM. Whenever we unpause the container again, then the processing will start again. Okay.
Got it. So there is another question actually.
Mm-hmm.
So you said actually Docker daemon regarding so Docker daemon, there are two services like, right? Docker service and Docker socket. So what is the use of socket? I know Docker service mostly it's like maybe
Docker sockets are used for listening the request.
request. Okay. Service
If
also
you
it's a perform both same.
Services are used to execute the request. If you give a command, who will execute that? The services will execute. First, if at all the service has to execute, someone has to listen. No.
Correct.
If I say that you need to learn Docker, so if you are not putting your headphones, or else if you are not hearing through your ears, how you are going to process what I have given? Okay. So when I give the command, the Docker socket will be opened so that the command will be captured by the Docker socket and it will give it to the Docker service, and Docker service will process the request and give the output for you. Okay.
Got it. Yeah. Thanks.
Right. Questions, guys? So that's about your Docker architecture and Docker lifecycle. Tomorrow we will start working with the Docker, and today is the last demo, guys. And from tomorrow onwards, we won't be there won't be any what I can say demos. Who has enrolled for the session, they will be given with a new URL or else new link. Through the link only you can join into the sessions. Okay. Any questions? The first week you will be having some hiccups, guys. Why? Because if you there will be another add-on batch, like I don't know, maybe if you there will be a little bit hiccups will be there, I will tell you, but don't forget to join the session. Okay. So tomorrow you will have a very interesting session, that is Docker networking, which will be very, very interesting. What is Docker networking? How we can create the custom network like that. And then we will be going ahead into the concept of Docker images. Most probably tomorrow I will complete the Docker network.
Sir, can we get the recording of these sessions?
Yeah, you will get this. You will get all the recordings. Don't worry.
To whom should we contact?
DURGASOFT. If you reach out to the DURGASOFT, they will provide you the recording. Or else in the YouTube also, the recordings are available. You can go to the YouTubes, but in YouTube there will be several sessions, different sessions will be there. But if you want the recordings, you can contact with DURGASOFT. If you enroll for the course, then they will provide a Google Drive access. So from the Google Drive, you will get all the recordings. Okay, then. Have a nice day, and we'll meet in the next session, guys. Bye. Thanks. Thank you all.